Hi, everybody. We're going to take a look at number 12 now from the Yearly Review 5 assignment. What is the area of the following kite? All right, now remember you have a formula sheet for the sixth grade that I always attach. But the formula for the area of a kite isn't on there. I mean, you could split it into different triangles, find the area of the triangles, and add them all together. But if you just remember the formula for the area of a kite, you're going to find this is a lot easier. So to find the area of a kite, you take 1/2 times diagonal 1 times diagonal 2. So what are the diagonals? Well, the diagonals are the length, I'll call that diagonal 1, and the width, I'll call that diagonal 2, of the kite. Actually, it doesn't even matter which one you call diagonal 1 and which one you call diagonal 2 because you're just going to multiply them together and then find half of that. So anyway, diagonal 1 here is 12 plus 10, which is 22 feet. Diagonal 2 here is 7 plus 7, or 14 feet. So we have to multiply 22 times 14, and then, of course, find half of that. Okay? So, you can just grab a calculator and go 22 times 14, and you get what? 308, I think. And then cut it in half by dividing by 2, and you'd get 154. But I think it'd be a lot easier just to find half of 22, which is 11. Okay? And then take 11 times 14. And again, you can use a calculator to do this, but that will equal 154 square feet. Okay? But again, go ahead, use a calculator for this if you wish. All right, number 13, Shaquille attempted 120 free throws and made 84 of them. What is the relative frequency of making a free throw? Relative frequency is a term you need to know. It means the same thing as experimental probability, which simply means instead of what you would expect will happen, it's what actually does happen when you give something a try. Okay, and what happens here is Shaquille gave it a try 120 times. He attempted free throws. All right, so he made 120 attempts. He made 84 of them. I can write that as a ratio, 84 out of 120. Okay, now if you want to figure out then what is the relative frequency of making a free throw, that's it, 84 out of 120. Now that's fractional form. I could simplify that too, which would be what, like 7 out of 10 if you simplify it. And I'm just dividing both of these by 12 to get there. That's my greatest common factor of these two numbers. So I get 7/10. Otherwise, you can divide these. The fraction bar always means divide. Okay, so we can do 84 divided by 120, and you can use a calculator to do this. And let's see what we get. 84 divided by 120 equals 0.7. See how the 7 is in the tenths place? We would read this as 7/10, which is what we have as a fraction. Now, as a percent, you then take your decimal point and move it to the right 2 spaces, and I have to fill in this space here with a 0, and we get 70%. Usually when shooting free throws, they talk about their free throw percent, and so it makes sense to have 70% here for our answer. What is the relative frequency of making a free throw? It looks like Shaquille made 84 out of 120, which is 70% of his free throws he made. Okay, actually, Shaquille O'Neal was a terrible free throw shooter. I'm not even sure he would have been that good to make 70%. All right, numbers 19 and 20 are both working off of this figure right here. And for number 19, it says find the measure of angle A. So I'm looking for angle A. Here it is right here. And let's see what we do here. I do notice I'm going to make my line a little bit thicker so you can see this more easily. This angle right here is a 90-degree angle. I know that because this angle over here is 90 degrees. And so this has to be 90 degrees to equal 180 degrees, which forms this straight angle here. So since this totals 90 degrees here, if this part is 33 degrees, I could find that part by subtracting 33 from 90. So I'm going to do that, 90 minus 33. That'll give me the measurement of angle A. All right, 3 from 0, well, I need to do some regrouping. Well, I'll make this 9 and 8. This becomes 10. 10 minus 3 is 7. 8 minus 3 is 5. So it turns out angle A is 57 degrees. 57 plus 33 does equal 90 degrees. These two angles right here, angles that total 90 degrees, are known as complementary angles. Angles that total 90 degrees. Complementary angles. Okay? Now for number 20, and I'm going to leave number 19 up here so you can see that as well. I'll just switch colors. For number 20, it says, let's find the measurement of angle B. What is the measurement of angle B? And look how large it is. It's a really large angle here. It's an obtuse angle. And I see it is right next to this 33-degree angle here, just like angle A was right next to it. So if you combine angle B with that 33-degree angle, together you see how they would form this straight line here? It's a straight angle. This is 180 degrees here. All the way from here over to here. That's 180 degrees. And if this angle is 33 degrees, I could find angle B by subtracting 33 from 180. And so I'll do that. I got to do a little regrouping here as well. I'll make this 8 a 7. This becomes 10. 10 minus 3 is 7. 7 minus 3 is 4. And then I have the 1 here. So this angle B here is 147 degrees. Okay? So that's my answer for number 20. The measure of angle B is 147 degrees. 147 plus 33 equals 180 degrees. These angles that are adjacent to each other here and total 180 degrees are known as supplementary angles. Supplementary angles total 180 degrees. Okay, so together I'll make this a little larger here. You can see those two angles are totaling this 180 degrees that you see right here. Okay, those two angles together. So it's 147 degrees for angle B, and it's, what was it for angle A? 57 degrees for angle A. All right, that's it. I'll see you later, everybody.